Hi. Now the next method for finding the solution of a linear system of equations is Rouche's method. The steps are: first we form the augmented matrix AB, that is coefficient matrix, and the constant matrix we join together, that is augmented matrix. First we form the augmented matrix. Then from the echelon matrix we find out the rank of AB augmented matrix and rank of A. Same procedure like Gauss elimination method. That is, like Gauss elimination method, we form the echelon matrix and we find the rank of AB and rank of A. And the next step is, if rank of AB is not equal to rank of A, then the system is not consistent and will have no solution. If rank of AB is equal to rank of A is equal to n, then the system is consistent and unique solution. And if rank of AB is equal to rank of A and less than n, that is a number of unknowns, then the system will possess infinite number of solutions. Okay. Now we shall move on to some problems. Now the first question: solve the system of equations x plus 2y plus z equal to 0, 3x plus 2y plus z is equal to 2, 2x minus y plus 2z is equal to 5, 5x plus 6y plus 3z equal to 2, and x plus 3y minus z is equal to minus 3. There are 5 equations here, and how many unknowns? 3 unknowns, that are x, y and z are the unknowns here. So first we have to form the augmented matrix. So the augmented matrix is matrix AB. AB is equal to augmented matrix. Matrix AB is equal to, what is the augmented matrix? 1, 2, 1, 0. We have to write the coefficients and we have to write the constant term also. So 1, first row is 1, 2, 1, 0. Second row is 3, 2, 1 and 2. That is 3, 2, 1, 2. Third row 2, minus 1, 2. And last element 5. Here 5, 6, 3. 5, 6, 3 and last element is 2. And the last row is 1, 3, minus 1, minus 3. That is 1, 3, minus 1, minus 3. So this is the augmented matrix. Okay, now we are going to reduce this matrix in echelon form. So what is the procedure? Here the first element is 1. Now we have to make all these elements below 1 as 0. These all elements we have to make them 0. Okay. This is equivalent to, look at this, we have to write the first row as it is 1, 2, 1, 0. Now the next step is, here we have to make these 3 as 0. For that, what is the elementary transformation? We have to multiply this row by 3 and subtracted from this we get 0 here. That is, the transformation is R2 minus 3 times R1. Okay, so I am writing here the transformation. R2 gives R2 minus 3 R1. So what is the elementary transformation here? R3 gives R3 minus 2 R1. Okay. Now the next element is 5. So we have to, R4 gives R4 minus, we have to multiply the first row by 5 and subtracting from R4. That is 5 R1. Also R5. R5 gives, what is R5? We are simply subtracting R1 from R5, we get 0. So R5 gives R5 minus R1. So these are the transformation. Now performing these transformations in all these rows, first element we get 0 here. Now here R2 minus 3 R1, that is 2 minus 3 into 2. 2 minus 6. 2 minus 6 is minus 4. Next element is 1 minus 3, that is minus 2. Last is 2 minus 0, that is 2. Now the next element, this is 0 here. Now minus 1 minus 4, we have to multiply this element by 2. So minus 1 minus 4 is minus 5. Next element 2 minus 2, that is 0. Next 5 minus 0, that is 5. Now coming towards the fourth row, we get the first element 0 here. Now here 6 minus 10. 5 into 2, 6 minus 10, we get minus 4 here. Now 3 minus 5. 3 minus 5 is minus 2. Here 2 minus 0, that is 2. Now the last row, first element is 0. Here 3 minus 2, R5 minus R1, 3 minus 2, we get 1 here. Minus 1 minus 1, that is minus 2. Minus 3 minus 0, that is minus 3. So this is the second matrix. Okay. Now we have to make the elements below. Now we are coming to the second row. The leading element is minus 4. We have to make the elements below this minus 4 as 0. That is, we have to change this minus 5, minus 4 and plus 1 to 0. Okay. Now, which is equivalent to first row and second row become fixed. So 1, 2, 1, 0. And second row is 0, minus 4, minus 2, 2. Now we have to make these elements 0. For making minus 5 0, we have to multiply this row by 5 by 4. 5 by 4, multiplying by 5 by 4 and subtracting from this row, we get 0 here. So the transformation is R3 gives R3 minus 5 by 4 R2. That is the transformation. R3 gives R3 minus 5 by 4 R2. Okay. Now here, coming towards this element, here it is minus 4. Minus 4 minus minus 4 is 0. So the transformation is R4 minus R2. R4 minus R2, we get 0 here. So R4 gives R4 minus R2. Now the last element is 1. For making 0 here, we have to multiply this row by 1 by 4. And adding with this, we get 0 here. So R5 gives R5 plus 1 by 4 R2. So these are the transformation we are going to perform in this matrix. So this element is 0 and this element becomes 0 by this transformation, and here 0 minus, what is the transformation? R3 minus 5 by 4 R2, that is, here it is 0. 0 minus 5 by 4 into this element is minus 2. So minus 2. So minus 2, 4. Here we get 2 here, minus into minus plus. So the element becomes 5 by 2. We get 5 by 2 here. Now the next element is 5. So we are performing 5 minus 5 by 4 into 2. Here also we get 5 by 2. 5 minus 5 by 2. 5 into 2 we get 10. 10 minus 5 by 2. 10 minus 5 by 2 is 5 by 2. So here also we get 5 by 2. So the third row is over. Now coming towards the fourth row. Here these two elements I am writing 0. Okay, this becomes 0 by this transformation. Now here, what is the transformation? R4 minus R2. That is minus 2 minus minus 2. Minus 2 plus 2. That is 0. Here 2 minus 2. 2 minus 2 is also 0. So that row completely becomes 0. Now coming towards the last row. What is the transformation? R5 plus 1 by 4 R2. So this element is 0. This element becomes 0. 0, 0. And coming towards this element, minus 2. That is minus 2. R5 is minus 2. Minus 2 plus 1 by 4 into R2. That is 1 by 4 into minus 2. 1 by 4 into minus 2. Here 2. So that is minus 2 minus 1 by 2. Minus 2 minus 1 by 2, we got minus 2 minus 1 by 2, that is multiplying, taking LCM, we get minus 4 minus 1 by 2. Minus 4 minus 1 is minus 5. So this element is minus 5 by 2. Okay. Now what's the last element? The last element is minus 3. Minus 3 plus 1 by 4. Minus 3 plus 1 by 4 into R2. R2 is 2. Okay, so here it is 2. So minus 3 minus 3 plus 1 by 2. 2 into 3 is 6. Minus 6 plus 1. Minus 6 plus 1 is minus 5. Minus 5 by 2. Here also we get minus 5 by 2. Okay, so using this transformation we got this matrix. Now this matrix is equivalent to first row 1 2 1 0 0 minus 4 minus 2 2 0 0 5 by 2 5 by 2. Next row 0 0 0 0. Now we have to make this element 0 because coming towards the third row, the leading element is 5 by 2. We have to change all the elements below this 5 by 2 as 0. This element is already 0. We have to make this element also 0. So for making this element 0, what is the transformation? Adding these two rows, we get 0 here. So R5 gives R5 plus R3. That is the transformation. So I am writing here R5 gives R5 plus R3. So we get 0, 0. This element becomes 0. Last element also by adding those two elements we get 0. 5 by 2 plus minus 5 by 2. That is also 0. So the reduction completed. Look at this. These two rows become completely 0. Now we have to write the rank of the matrix. In Gauss elimination method, after completing this process, what is the procedure? We simply write this matrix in equation form, that is back substitution. But in this method, we have to write the rank of AB and rank of A, and we have to say either this system is consistent or not. That is the difference between Gauss elimination method and Rouche's method. So first, after completing the procedure, after completing the row reduced echelon form, we have to write the rank of AB and rank of A here. So what is rank of AB? Here rank of AB is equal to how many non-zero rows? 3. So rank of AB is equal to 3. And what is rank of A? Look at this, rank of A is also 3. So this is equal to rank of A. And how many unknowns are here? Now rank of AB is equal to rank of A is equal to 3. Both the ranks are equal. Rank of AB and rank of A is equal. So the system is consistent. Therefore the system is consistent. The system is consistent. Okay, the system is consistent. Now, also rank of AB is equal to rank of A, and this is equal to number of unknowns, isn't it? Number of unknowns, how many unknowns are here? 3 unknowns, X, Y and Z are the unknowns. So rank of AB equal to rank of A is equal to 3, and this is equal to number of unknowns N. Therefore the system will possess unique solution. Therefore system will have unique solution. Unique solution. Now we have to find out the solution by back substitution. Okay, now we have to write this matrix in equation form and we have to find out the solution. Now first equation is x plus 2y plus z is equal to 0. Second equation is minus 4y minus 2z equal to 2. And the last equation is 5 by 2 z equal to 5 by 2. So from the last equation we can find out z. What is z? Therefore z is equal to 5 by 2 divided by 5 by 2, that is 1. We get z as 1. Now by substituting the value of z in this equation, we will get the value of y. Now minus 4y minus 2 into 1 is equal to 2. That is minus 4y is equal to, what is minus 2 into 1? Minus 2. Minus 2 and minus 2 goes towards the right. We get 2 plus 2, that is equal to 4. Therefore y is equal to 4 divided by minus 4, we get minus 1. Okay. Now substituting y is equal to minus 1 and z equal to 1 in the first equation, we will get the value of x. Okay. that is x plus 2y, 2 into minus 1 plus z, what is z? 1 is equal to 0. That is x minus 2 plus 1 is equal to 0. That is x minus 1 is equal to 0. Therefore, x is equal to 1. So, we will get x equal to 1. Therefore, what is the solution? Solution of the given system is x is equal to 1, y is equal to minus 1 and z is equal to 1. Okay. Thank you.